Hey, CP Math 1, this is Mr. Roberts at Shasta High School. Good work in class today. Hey, let's take a quick review of some of the things we talked about. So today in class, we talked about, hey, how do you find the equation of a line if you don't know the slope and you don't know the y-intercept, right? You basically got nothing except for either some points or a bunch of points. And we did this with the design A, right? We went through and we found all of the slopes for those four different segments. We found the y-intercepts and we wrote the equations of those lines. We also did that with this table, right? We found the slope that's represented by the growth in this table. This table was a mess. The x's didn't grow by one nicely. The y's, it's kind of hard to predict what's going on. But using our calculator and our knowledge about the slope, we were able to calculate the slope and figure that out. So what I want to do is take a look at one of the problems that's part of tonight's homework. It's this problem. And in class today, we said, hey, this little segment that I've highlighted in red, this is a pretty easy segment because you can see as it goes from left to right, my y values aren't changing at all, right? Y is 45 when x is 89, and y is still 45 when x is 130. So there's no growth at all, which tells me that the slope of this line has to equal 0. So the slope is 0. The other thing I see is, look, no matter where I'm at on this line, it's always the case that y is 45. Y is 45. So for horizontal lines, right, that value of y ends up being the y-intercept, because if I took this line and I just extended it a whole bunch this way, eventually it's going to hit that y-axis. So the equation of that line in red is simply the line y is equal to 45. Now we'll do one more of these, and you'll have two that you're left you have to do completely on your own. But let's take a look at this one. I'll highlight it in green. What is the equation of this line? Right? What is the equation of that line? Well, we know a couple of things, right? We've got some x values and we've got some y values. We can see that y is 144 here and y is 55 down here. And up here we see that x is 21. And down here we see that x is 64. So if I wanted to, I could write the slope of this line, and I'm just going to look at the change in my y's, and I'm going to divide that by the change in my x's. These are my y's. The second coordinates are my y's. The first coordinates are my x's. And I could say, hey, the slope is going to be 141 minus 55 divided by, I'm going to go 21 minus 64. So you can see I'm following the same pattern. In this case, I'm starting with the top point, the point up above, 144 minus the lower y, 55, and then 21 minus 64. Our favorite preferred way of calculating the equation of these lines is to quickly grab our friend, our trusty friend, the TI SmartView calculators. So these are always available to us in our classroom. Let me turn this on right here. Let's see, there it goes. So if I want to calculate this value, right, I'm just going to pull up the fraction template, which is this key. And as I pull up the oh, wait, where'd this go? There it is. I'm going to, oops, clear this. I'm going to pull up the fraction template, which is this key. Got it. And then the numerator, I'm going to take 141 and I'm going to subtract 55. In my denominator, I'm going to place the 21, right, that top x value, minus 64, the lower x value. And I get that the slope of that line is -2. So for the green line, we know slope m is -2. Right, that's a big chunk of it, but we're not done, because in addition to the slope, we need to figure out what our y-intercept is. And we know that all lines can be written in the form y equals mx plus b, with the exception of vertical lines. Right? This is clearly not a vertical line because I can see that my x's are different. One x is 21 and 164. So this is certainly true for all lines except for vertical lines. And what I'm looking for is b. I'm trying to figure out what my y-intercept is. So what I know is that, hey, if y equals mx plus b, then certainly y minus mx would equal b, would equal my y-intercept. So I'm just going to use this quick formula to figure out what the y-intercept is. And I'm going to do this in the following way. I'm going to use this top point. There's an x value right here at 21, and I'm going to put that in for x. There is a y value I'm going to use up here at 141, and I'm going to place that in for y. And the other thing that I know is I've calculated my slope. My slope was -2, and I'm going to place that in for the m right there. So if I want to figure out my y-intercept, I'm just going to say y, which is 141, minus, and then I always put this next part in parentheses, 141 minus m, which is -2, times x, which is 21. So let's evaluate that. I'm going to take 141, and I'm going to subtract. I'm going to go ahead and grab -2. So it's a -2 times positive 21. And when I evaluate that, my calculator tells me, hey, you get a value of 183. So my y-intercept is way off. I'm sorry, it's not y. My y-intercept, which is b, is way off at 183. This means that I've got an equation for this green line, right? I think we're ready to write this down. This green line has the equation y is equal to -2x plus 183. Now, I just realized I'm writing that off to a place where you can't see that. Let me turn off the calculator. So there it is, right? Y is equal to -2x plus 183. So that's a thing, right? I did that thing. How do I know if I'm right? Well, I want to check the correctness of this. And I'm going to do it. Let's see. This time I'm going to do it by using my calculator and its table function. So let's go ahead and bring the calculator back up. And on it, I'm going to hit this table function. So when I hit the button that says table, oops, not that one, not the tangent key, table, right? When I hit table, I get the last equation I was dealing with. I'm going to delete that. Can I just hit clear? Yep, just clear that. And I'm going to type in what I think the equation is for this green line. I think it's -2. So I'm going to hit the opposite of 2 times x, and then plus 183, and I'll press enter. Now, I've been showing you how I use this with the auto feature, but I'm going to come down to a place where I'm going to ask my calculator to ask me what x I want to look at. So I'm going to switch it to ask, and then I'm going to go to OK. Now, this is what ask looks like. I can type in an x value, and when I press enter, it's going to tell me the y value that goes with it. Now look on our screen. We know that when x is the number, we got it right here. We know that when x is 21, y should be 144. So what I'm looking for when I type in 21, I'm looking for a y value of 144, and we got it. So it certainly works for that point, but it really has to work for both points if I want to ensure that it's actually on that line. So I'm going to take it one more step, and I'm going to go ahead and enter the 64, right? I'm going to enter the 64. Oh, where's that pin at? I'm going to enter the 64, and it better give me 55. So let's type 64, doop, doop. And when I press enter, it says, uh-oh. Oh, I put 65. I got to put... I thought, oh my gosh, I don't have that. 64, it gives me, oh, okay, there we go. So when I type in, when I give this function, when I give this equation, the number, when I give y equals -2x plus 183, when I give it the number 64, it gives me 55. And when I give it 21, it gives me 141. So I'm confident that y equals -2x plus 183 is the equation of that line. And before I quit tonight, I want to do one more problem. I want to do question 104. This is also part of the homework, and it's a problem that would involve using multiplication by 1. So the question says, if you are traveling at a speed of 50 miles per hour, so immediately I'm thinking of a 1. And this one says that for every, if I want to go 50 miles, I have to my car or whatever I'm traveling in 1 hour of my time. I can also flip that. I could say, hey, for 1 hour of time, I travel 50 miles. And it says, oh, how many feet per second is this? Oh, okay. So I've got miles per hour, and I want to convert that into feet per second. Well, let's take care of the time part first. Miles per 1 hour. So I want hours to leave. And if I wish hours to leave, I'm going to put hours in the numerator because they were in the denominator. And I'm going to go to, it says per second, but I'm going to go to minutes first because I know that one. So I know that 1 hour is the same as 60 minutes. So if I look at this problem right now, what do I have? I've got miles. I've got 50 miles per hour times 1 hour is 60 minutes. But because these units, this hour will cancel with hours, I'm now looking at miles per minute. Right? So I was able to make the conversion from miles per hour to miles per minute. I want to get the minutes to go away, so I'm going to multiply by another minute. And this time, instead of being, I'm putting this here because I want minutes to cancel with these minutes. I know that, let's see, I know that 1 minute is the same thing, same amount of time as 60 seconds. Again, the idea is because these are equivalent, right? 1 hour is the same as 60 minutes. I can multiply by that number 1. 1 minute is the same as 60 seconds. I can multiply by that number 1. So my minutes are leaving, and what I have now is miles per second. So we're now looking at a speed of some number. I don't know what the number is yet, but it's miles per second. Last thing I have to do is I have to leave miles because I want this measurement in feet per second. I definitely have the second part done, but I've got to get into feet. So I'm going to bring in one more giant 1. And I want my miles to go away. And I just so happen to know, and we've talked about this in class, that 1 mile is the same as 5280 feet. 5,280 feet. Now, we've talked about this particular fact often, but on a test, I don't expect you to have these memorized. I will have some useful giant 1s on the whiteboard that you can look at. But it is certainly true that 5,280 feet is the same distance as 1 mile. What's great is if I look now, finally the miles are gone with miles, and the only thing I'm left with for my answer here is my units are feet per second. So now that I have my units are correct, feet per second, let's figure out what the number is. In the numerator, I've got the number 50 times 5280, right? I got the 50 and the 5280. Multiplying by these 1s isn't necessary, doesn't change anything. In the denominator, I've got 60 times 60, and multiplying by these 1s don't change anything either, so I got that. And what are the units? This is now feet per second, SEC. So what's the number? Well, that's great. That's a calculator question. Let me grab that. And in the numerator, I'm going to go ahead and place, let me clear this table. I'm going to place in the numerator, boop, need the numerator. I'm going to do 50 times 5280. So 50 times 5280. And then the denominator, I'm going to place 60 times 60. 60 times another 60. By the way, that's the same as 60 squared. And when I press enter, it says, that's nice. Let's go ahead and convert that into a decimal. And it says 73, and I know that's 73 and a third, 73.33. So I'm going to say my speed is about 73.3 feet for every second, right? So every single second that goes by, I travel another 73.3 feet. Now, fun fact, if you want, you can ask Siri or whatever that, hey, can convert 50 miles per hour into feet per second. And this is exactly what they'll say, right? But the thing is can you do that? And certainly, can you do it with the idea here of dimensional analysis multiplying by 1s? All right, that's it. 14 minutes. What the heck? Talk to you later.